All right, let's get started here. In today's lesson, we're going to find the slope of a line. We're also going to find the slope from a table, followed by talking about different types of slope, moving into what slope-intercept form is, identifying slopes and y-intercepts, and using slope-intercept form to graph. Let's do a quick review. Yesterday, we talked about what slope is. We said slope is the change of y over the change of x. It's also known as rise over run. You can also find slope by taking your y2 minus your y1 and putting that over x2 minus x1. You'll see me reference these three different examples throughout the lesson, so pay close attention to when we use each one of these examples. All right, let's first start with finding the slope of a line. If we look at our graph here, you'll notice that our line is decreasing. So right off the bat, you should know that your slope is going to be negative. However, it's not just asking you if it's a negative or positive slope. It's asking you to find the slope of the line. So let's go ahead and reference rise over run. Rise over run is used to find slope of graphs. You simply count the change of your y's and put that over the change of your x's, also known as your rise, up and down, over your run, left to right. If I look at this graph, I'm rising up 2. So my rise in this graph is going to be 2. However, when I run left to right, you'll notice that it's going left 5. So the run in this graph is negative 5. Therefore, the slope of this graph is negative 2 over 5. If I look at my second graph, you'll notice here that the slope is positive. So I can go ahead and write off to the side that this slope will be positive. However, we need to find the rise over the run. I first need to count my rise. I'm rising from this point all the way to this point. Therefore, my rise is going up by 1, 2, 3, 4. My rise here is 4. If I look at my run, you'll notice that I'm going to the right in this direction. You'll count that I'm going to the right by 1, 2, 3, 4, 5, 6. So my run here is 6. However, we need to reduce to the lowest form. 4 and 6 both share a common factor of 2. So if I divide 4 by 2, I get 2. And if I divide 6 by 2, I get 3. So the slope of this graph is 2/3. Let's now move into finding slope from a table. Finding slope from a table is easy. You can just go ahead and calculate the change in your y over the change in your x. You can do that by either finding the constant change from y to y or by using y2 minus y1 over x2 minus x1. Go ahead and pick 2 points. So in my case, I'm going to pick the points 10, 8 and 13, 2. If I write those as coordinate pairs, I get 10, 8 and I get 13, 2. You'll notice that 10 and 13 are both x's, and you'll notice that y and 2 are both y's. I'm just going to label them x1, y1, and the next point, x2, y2. The number is called a subscript. It's just to tell us that the x's and y's here are different. All right, I'm going to go ahead and go into taking my y2 value, which is 2, minusing 8 from it, and then going to my x value, x2, which is 13, and subtracting 10. When I solve this problem, I get 2 minus 8, which is negative 6, over 13 minus 10, which is 3. If I reduce this fraction, I get a slope of negative 2. Looking at my second table here, I can go ahead and I can notice right off the bat that our y's are staying the same. What does this tell us? It tells us there's no change in our y, which means our change in y in this problem, our change in y is 0. It's staying the same. Over our change in x, which is going up by 2. 0 divided by any number is just going to give us 0. So the slope of this table here is 0. All right, let's move into the different types of slope. You can either have a positive slope, which rises from left to right. You can have a negative slope, which is going to fall from left to right. You can also have a slope of 0, which is a straight horizontal line, or you could also have here an undefined slope, which is going to be a vertical line. These are the three types of slope here. We have undefined, we have 0, we have negative, and we also have positive. All right, identifying slopes and y-intercepts. This equation right here is called the slope-intercept form. It tells us that m, in this case, is our slope, and that b, in this case, is our y-intercept. I want you to take note that the y-intercept is always written as a coordinate point, 0, and whatever y is. The reason why is because no matter what, your y-intercept's x value will always be 0 because that is where it intersects the y-axis, therefore making it a y-intercept. Okay, so with a y-intercept, x is always 0 because that's where your line intersects your y-axis. That's important to note, so if you need to write that down, I would definitely encourage you to do so. All right, let's use this time to talk about this equation right here that I'm going to highlight in yellow. Okay, this guy right here. We need to work on finding the slope and the y-intercept. So I'm going to stick with blue for slope, okay, and I'm going to stick with green for the y-intercept so that we have some consistency here. All right, our slope here is going to be the number that's always in front of x. So if we're looking at this equation, you'll notice that the slope in this problem is 3. So our constant rate of change, or our slope in this problem, is 3. Or you could say 3 over 1. Our y-intercept is whatever follows x. Okay, so in this case, it's minus 4. So you would say that your y-intercept in this problem is 0, negative 4, because that's where your graph intersects the y-axis, making x 0 and y negative 4. If we look at the next problem, which I will highlight in red, you're going to notice that it doesn't really fall in the slope-intercept form. So we're going to go ahead and work to rearrange it here. In order to do that, we kind of have to analyze the problem. In this case, our slope here is 0. So if I were to rewrite this equation, it would be y is equal to 0x plus 6.5. Now, why they took out 0x is because no matter what x is here, okay, it's always going to be 0. Okay, so in this case, our slope is 0. So whenever you see an equation that reads y equals a number and there's no x on the other side of the equation, okay, so in this case, this example, your slope is always 0. Okay, it's always 0 here. However, this equation does have a y-intercept, and its y-intercept is 0, 6.5. All right, if we look at our next equation, which I'm going to highlight in purple. Let's do purple this time. You'll notice that it's also not in slope-intercept form, so we need to rearrange it. That's where solving literal equations comes in handy. Okay, so first we're going to add 5x to both sides, and that's going to give us negative y is equal to 5x minus 2. Except y can't be negative here, so we have to divide everything in our equation by negative 1 to give us y is equal to a negative 5x plus 2. Now it's nicely in slope-intercept form, so I can go ahead and identify my slope. My slope in this problem is going to be a negative 5, and my y-intercept in this problem is going to be 0, 2. I encourage you guys to watch, replay everything as you're kind of going through. I know this is a lot of information, so sometimes rewatching is definitely helpful. All right, now we're going to talk about using slope-intercept form to graph. So in order to graph in slope-intercept form, your equation must be in slope-intercept form. So if we review off to the side, slope-intercept form is y is equal to mx plus b, where m is going to be your slope. Okay, m is your slope. And b, in this case, is going to be your y-intercept. And keep in mind, it follows the coordinate point 0, y, because the y's will change because you have different y-intercepts, but x will always remain 0 because if you look at your graph here, this is your y-axis, right? So if your line's intersecting your y-axis, x is going to be 0. Okay, so keep that in mind. This is the y-axis. X is always 0. All right, so we need to go ahead and graph this equation. It's not in slope-intercept form, so we need to make it in slope-intercept form. We're going to subtract by 2x on both sides. That's going to give us y is equal to a negative 2x plus 2. All right, now we know our slope, which is negative 2, and our y-intercept, which is 2. The first thing we do in graphing in slope-intercept form, and I'm going to make a little list here, is plot your y-intercept. So I'm going to go ahead and take my y-intercept, which I know is at 0, 2, and I'm going to plot it right on my graph. All right, next is to then use your slope. Use slope for rise over run. In this case, my slope here is a negative 2. Okay, so if I were to write that off to the side, m equals a negative 2. Okay, except it only has a rise, you may say, but it does have a run. The run is just 1. So whenever you have a whole number, the run is always 1. Okay, the run is always 1. So I'm going to take my y-intercept, and I'm going to go down 2, and I'm going to go to the right 1. Why did I go down 2? Because my slope is negative. I could also go up 2 to the left 1. That works as well. And then you'll just continue the pattern to draw your line. I know it's not a perfect line, but this is how you graph in slope-intercept form. All right, we have finished up our lessons. I'm going to ask that you guys try the monitoring progress all by yourself. Then when you become confused or maybe you want to check your work, go ahead and click play on the video and it'll walk you through the answers. Okay, good luck. All right, hopefully you looked over all your answers for the guided notes. Don't worry, we will spend a lot of time next week going over all of this. I just wanted to give you guys kind of a pre-teach before we get really into the nitty-gritty of it all. Please make sure that you go back to the packet that I gave you yesterday for homework and look at the answer key on Schoology. It's under unit number 2. Homework folder. Go through, check your answers, make sure you're correct. If anything is incorrect, please fix your work. Have a good weekend.